one of the problems from the practice exam was an elemental analysis problem. In that problem, you're given mass values of carbon, hydrogen, iron, and sulfur that's determined by experiment. And you're asked to identify the compound's empirical formula. You're also given its molar mass, and at the same time asked, what is the molecular formula? So from all of this data, we need to calculate empirical formula and molecular formula, which could be the same, but we'll have to determine that a little bit later on. Now, the format of which we've been given the data is we have 10.81 grams of carbon, 1.111 grams of hydrogen, and then grams of iron and sulfur as well. A molecular formula, or an empirical formula, or a molecular formula requires moles. It's a molar ratio. So, we have grams, we need to convert to moles. So what we do for each particular element is we convert it to moles. In this problem, you're given the gram quantities of each element. In class, I did it based on percentage, which you then convert to grams. So there are lots of different ways you might see a problem like this formatted. I could have given you a percentage, and then you'd have to figure that out. Or something else. I could have given you the molar ratio, but obviously if I gave you the molar ratio, it'd be a much shorter problem. So, 10.81 grams, to convert it to moles, 12.01 grams of carbon is 1 mole of carbon, 0.9 moles. I'm going to leave the unit off, and you'll see why in a second. Grams of hydrogen. So I'm converting grams of hydrogen to moles of hydrogen. Again, notice this is hydrogen monoatomic, not diatomic. We're not talking about hydrogen gas. We're talking about just as an element. So that gives us 1.102 moles of hydrogen. So grams of iron to moles of iron, and finally, we convert the sulfur from grams of sulfur to moles of sulfur. And it's understood that these are all in units of moles. The reason I'm leaving off moles of carbon, moles of iron, and so forth is because we're going to be using this in a second. Now, my answer isn't going to be carbon 0.9, hydrogen 1.1, iron 0.4, sulfur 0.1 moles for my chemical formula, for my empirical formula. Because we can't have a fraction of an atom. We have to have a whole number ratio. So, what we need to do, now that we have the molar quantities of each one of these, now we have to figure out how to get this into a whole number ratio. And simply from math, well, if I have fractional values and I want a whole number ratio, I divide through by the smallest number. So, 0.1 is the smallest number. So when I divide it by itself, that gives me a ratio of 1. And then we just repeat this for each one of these. Gives me a ratio of 4. Gives me a ratio of 11. And that gives me a ratio of 9. So now, our empirical formula is C9, H11, Fe4, S, 1 sulfur. Again, grams to moles. I didn't go over that in detail because at this point you should know how to calculate grams to moles and so forth. And by the way, when you do this particular calculation, if I were to get 4.03 or whatever, it's a whole number. It has to be a whole number. So I'm not worried about significant figures at this point because I know if this was, 3.998, it's going to round to 4 because I have to have 4 molecules or 4 atoms. I can't have a fraction or 4 moles. So we have our empirical formula, but we also want the molecular formula. That's where we have to use the molar mass. Now, to calculate molar mass, and I'm not going to show every step, what we need to do is we need to calculate the molar mass of just the empirical formula. And when you do that, this has a molar mass of 374.4 grams per mole. 9 times 12 plus 11 plus the molar masses of 4 irons and sulfur and so forth. Well, that's not the same thing. So we know the molecular formula and the empirical formula are not identical. What we need to do is figure out how many units of this equal that, right? In other words, is it double, is it triple, or so forth? And you don't have to guess because all you have to do is 1,124 divided by 374 gives me 3. So what that tells me is I must multiply my empirical formula by a factor of 3. If I divide it through, it was 10, it would be 10 times and so forth. So my molecular formula is going to be 3 times 9, 3 times 11, 3 times 4, and 3 times 1 for each respective element. C27, H33, Fe12, S3. So C27, H33, F12, S3, Fe12, excuse me, iron, 12 irons. That is my molecular formula. Run out of room here, sorry. So molecular. It's all blurred. To do this problem, to get to molecular, you need to get to empirical. As I said, there are some cases where the molecular and empirical formula are identical. So if the molar mass that had been determined by experiment would have been 374, 375, then you know that they were the same. But it was determined to be 1124. So 1124 divided by this molar mass, which is 374, is 3. So it's triple.